Okay, I think live now. I have already. Can anybody of you? Actually, it's a little bit quite some time ago that I did my last live stream. So if you can hear me and if the audio quality is okay, it would be nice if someone would drop me a comment. Hi. Can you hear me? Oh, perfect. Yeah, then we can start. That's fine. I tried a little bit the audio. Yeah, let's start. What we want to do here is I created a little program for the weekend, and what it does, it calculates images from the Mandelbrot set, which actually, if you haven't heard about it before, is in my opinion something quite impressive or amazing. That based on a mathematical formula, get this beautiful images. And actually, what it does is it does some. I'm not I'm not a math guy, yeah. So I can only give a very raw introduction. That for every point on the screen, it calculates an formula with imaginary numbers, and it checks if it converges against 0 or not, or against to another value. And depending on which value, it sets the color. Yeah, and reason actually, because I don't know exactly how it works, I ported a pretty old Dart version of Mandelbrot set, which was actually 10 years old and was using Dart to JavaScript at this time. And the fascinating thing is, if you can zoom in here, up, can zoom in, and will always find structures that are interesting. For example, let's zoom in on this here. And you see, we do it a little, go deeper in. Calculation takes more and more time. Let's zoom again a little bit. I don't know what you think, but I think this is absolutely beautiful. Which structures, and you see there it's actually these are called fractals because find the same structures that look like the overall structure again and again in smaller structures inside. Yeah. So you see here again, there's another one over everywhere there is one of this. Actually, they are called Applemans in Germany. In German, we have because they look like a little bit like an apple. Okay, so far this is all very nice. But as I said, you see, it takes a little bit for every update of the image because it has to do the full calculation. So what I want to do is let's switch over to the code. I don't know. Is the size of the font, is this okay? Because I guess this is too small. Or could you just give me a feedback on what you think? Still readable, or should I make it bigger? Hey, still someone there? Okay. Um. Okay. Good. So then that be okay. Yeah. Still bigger? Okay. This is I think this is the. I have to get used to the latency between what I say and when you see it and hear it. So I hope this is now okay. Wow. Okay. I won't look on. Good. So the current app doesn't really look very fancy. It's ah, it's just your basic stateful widget with the material app. I have a scaffold, an app bar, and then I have the widget. I call it the Mandel Explorer. And the Mandel Explorer itself is just a stack with a layout builder, so that my Mandel view knows how big it has to draw, and it has an um, and it has as the base element in the stack. It uses layout builder and then the Mandel view, and the Mandel view gets as parameters the size of the window, and it also gets the upper left in the mathematical coordinate system of the what do you call it, the coordinate system on the mathematical side. So because I make the calculations, I make in the this coordinate system with the upper left of minus 2.05 comma minus 1.1 and with a width of 3.0. Yeah. So and we map this coordinate system here onto our full width. Yeah. This is on the width on the screen. Yeah. So that should be fine. Now let's look have a look into the Mandel view, because everything else here, the positions, are just the floating action buttons. And if you see, I just manipulate with the set state the upper left, or here with I do it with a fraction of the current render width, because if we in the render width gets smaller, and if I would see the steps that I move the upper left at the same size, it would start jumping in very big steps. Yeah. So we do it like this. This was just try and error to figure out, okay, what works. The 30 works pretty well because it's more or less a tenth of this year, and I step at the beginning I stepped a tenth of one of 0.1. So this works just in all directions. And then I have the zoom in buttons, and in this case I reduce the render width, and at the same time I translate the upper left a little bit diagonally, so that I stay at the same place when I zoom in. Yeah. Yeah, the Mandel view. The Mandel view is also a quite straightforward stateful widget at the moment, and it is stateful because I decided to draw the images in a special way. There would have been possibilities. I could have used a custom painter, but then I would draw directly into the bitmap. And because I already had in my mind, I wanted to use several isolates to draw several areas of the whole images with separate isolates. I decided to not to use this way, but to draw completely in memory, and then display the memory as an image. Yeah, so we draw into a piece of memory, and then we draw this piece of memory as an bitmap image. And surprisingly, it is quite, yeah, it's not so easy to do this in Flutter. Because if we go here to the yeah, this is actually the what you have to do. With we have at the beginning we allocate an image buffer with the width and the height of our screen that we get passed in, and we allocate it as 2x32 because we have 3 8-bit color channels plus 1 8-bit for the alpha channel. Yeah, so 32-bit per pixel. And then we call render mandel. Okay, this is the same thing in the update widget. I allocate a new image buffer if the size of my screen has changed, and I call render mandel. And render mandel is the part where the magic happens. The first thing is I calculate the aspect ratio of my current window, because I want to have the rendered image the same aspect ratio as the as my window. And then I call the from the mandel class render data, and the render data gets an image buffer. It gets the upper left coordinate of the I don't know. Sorry, no, it doesn't. It gets the left upper it gets the upper left and the lower right coordinate of the image of the area that we want to render and display inside the bitmap. Yeah. So we have here x min, x max, x y, and y max, and I calculate it from the upper left and the render width. I use upper left and the render width because by this it's easier for me to handle when I go around in the area that we want to render. And as you see here, based on the render width and the aspect, I decide how high the area is that we want to render. Yeah, and I have to tell him, okay, how big is the bitmap, the actual bitmap that we want to render in. And after that, our Mandelbrot image is stored inside this image buffer. Yeah, I won't get into details how this is done, because this is mostly code that I just copied from somewhere else, because I'm not a math genius in this way. So if you want to have a deeper look in it, clone the project. It's on the on my GitHub. I added the link to the description, and yeah, then you can see how this is done. But so render data just creates a new image of the area that we want. Yeah? So, but this is just then we have the image inside the image buffer. Yeah. So we don't have the actual image that we can display. And here comes what is surprisingly difficult in Flutter. I was expecting that I could just pass in a raw bitmap of pixel to an image widget. Yeah, would have been what I expected. But it's actually far from that. What you need is there is a class called raw image, but the raw image does not take a list of pixel. It takes an image, a .ui image. So where do we get an .ui image from? Turns out, to get an image, codec, yeah, and the codec has to can produce us a next frame, and this next frame then has an image property. So this is and actually even this is not that easy, because not just instantiate the codec, you need an image descriptor, and an image descriptor finally has a parameter which is or the constructor raw that takes an image buffer. But even there we have to make another hoop, because I can't pass in just a list of just a uint32 list. I have to pass in an immutable buffer. And an immutable buffer I can finally create from an uint8 list, so that's fine. Image buffer image buffer.buffer as uint8 list, that's fine. I can pass this in. But the creation of the immutable buffer is an asynchronous process. So I can't just create it and pass it into our display. So what I do is in the display, I check. I have this memory. I have this member variable here, the frame to display, and the if it's not null, then I directly display it with a raw image. Otherwise, I display a circular progress indicator. This is, I think, pretty much straightforward. Then I have yeah. So what I do is and because of this, in render Mandel, called in git update widget and in init state, I call the asynchronous function from int8 list, but I don't await it. I use the other way we can deal with futures. I use the then method, and so I get here the immutable buffer. Then I pass this to the image descriptor raw and call instantiate codec, which gets me a codec, which also returns me a future. So I call then on this and call in here codec get next frame. And because of this is also an returns a future, I can then add another then frame. And if the frame is there, I call set state the frame to display with the frame that I just got decoded. Yeah. So this is a little bit, you have to jump through a lot of hoops to finally get your image encoded, I would say. Okay. If you have any questions, as always, just ask. I'm happy to answer anything. Um, it's only that I always I have this latency between what I say and I read you, so it take some seconds that I can react to what you want to know. So yeah. Now, how do we split this into multiple um, pieces? Yeah. The obvious thing I have this the Mandel view, because the Mandel view we will use it almost like it is. Yeah, we will later on this part here, or the render Mandel, we will later on isolate. But the first thing is what we have to do. We have to split the display on one from one big image to all tiles that we can calculate separately. Yeah, and that we do in main now here, and we do this by not using one Mandel view, but by using multiple Mandel views. Yeah, so let's think a moment. How do we do this? So yeah, we let's add another. Oh, okay. Wrong. Oh, stupid. Don't be surprised if I type a little bit strange. I'm still getting used to the VI key bindings, and so sometimes I still just make mistakes. So let's define final int tiles x as oh no, wait, because if I have otherwise the sizes will vary. Um, uh, File size. Let's do it 256 pixel. Okay. So what we do, what we don't now need in the build function that we can then that we need x and y pixel tile size number. Oh, not here. Inside the layout builder, I need it. So is this the size and the enable my key bindings. Oh, here. Yeah. Oh, okay. I think was Ah, okay. Cool. The analyzer is pretty good. It tells me that if I use the integer division, and yeah, it also looks a bit better, right? So if you haven't used it before, is the integer division. So um, right, okay, and yeah, now we loops, nested loops, yeah. It's just an for x. Plus plus. And actually, I can. My touch typing is sometimes not perfect. So well, in principle, we would almost. I can't do this. I would love to, but the problem is when I do this here is that I would just fall several times return. That's not fun. So have to do it differently. So we are still inside the tiny rows and columns, right? I'm really sorry. I'm a little bit out of little bit out of practice at the moment because yeah, I had some quite little bit tough times. So try do it the right way and do it in. So yeah. So we need a column or row. The rows are the columns. How we do it was the columns. The bubbles column. Yeah. So and inside here we will use the So, and we have the yeah. No braces at the end. Like, ah, this is the outer column. Ah, oh, yeah, this better now. Let's see if I made it correct. So we have a column, yeah, and in the column I do the epsilon tiles, yeah, this fits, and then in the row I do the X tiles, yeah. Oh no, that's stupid. I'm totally stupid. Can't use rows and columns. I have to use a position because we want to position it on pixel or on specific pixels, yeah, right? Oh wait, we are running on Windows. Okay, this is not what I expected. Oh yeah, sure. Okay, yeah, it makes sense to first thing. Let's here let's find the overflow. Oh, obsolete. Interesting. That the behavior instead. Okay. Bit that I path that I did Flutter development. Bit behavior. Called one. Oh, probably because I don't have an expand. Okay, let's get rid of the columns and this columns. And I was actually it was not wrong what I had before. In many aspects. Let's just go back there. Um, I was on the right track, but yeah, yeah, exactly. Hey Robert. Yeah, morning is going great, but but honestly, I really got a little bit rusty in really Flutter widget stuff. I have no problem with everything else in coding, but this is sometimes really yeah. Um, so what we want to do here is that inside the layout builder. So let's see. I moved the layout builder. Yeah, I moved the layout builder outside of the stacks. That's one of the things. But here it doesn't make sense. Um, oh, not so much. Only. Yeah, Robert, it is really it really takes a little bit of time to get used to them, but the advantage that I don't have to move my hands from the keyboard to the mouse is just worth it. Yeah, so that's definitely a good idea. And yeah, we can move this here. Found us the stack there. Yeah, fine. And yeah, this is totally okay. But I have to get out. Oh, somewhere like this. Now let's all the places bold. Ah, then I'm in the layout builder, and from there I return a stack. Fine, this is fine. Uh, this not? Yep. And no, not so. This looks way better. Uh, yep. Honestly, I wished we had. I like the idea. I like the four uh, inside inside stacks and columns or inside lists. I would say. Um, but I wished we had also the braces to yeah to define blocks more clearly. So let's see. I'm correct here. Stack. and then I add. Yeah. Now we are back on track. So this doesn't look much different now, because what I forgot to do is I did forget two things. So far we have not positioned the mandel view. Have we changed the size, and now the width and height is no longer this here, but it's tile size. Okay, which would be principle okay, yeah, but now we have to do the whole thing, and we wrap this here inside a and at right is no left. We start on left side. Left is X tiles multiplied by tile size. Ah, okay. Oh, okay. Name of for the top, but in case uh, so what do we expect? Yeah, almost. Okay, we have some rounding issues because I was expecting that we have the full things we are completely filled here. Let's see. Change this. Yeah. Let's just add one. But no, then we have to the division and do some rounding is better. So and heal. We heal. And you have just seen that I used the multi-cursor of .NET. Yeah, this looks perfect, doesn't it? But now we only have managed to we only have managed to multiply the whole image, and we want to split the parts that we calculate. And for this, we have to transform the our tile coordinates from the pixel into the mathematical coordinate system. Yeah, and we do this by we have to calculate here the we have the tile size. On the one side we have the tile size, which is the map tile size, yeah, and then we have the render tile size, so the one that we want to, and this is a final double. Okay, now math. Is I always get it wrong. Wait, I can't. Actually, I can't calculate here. Yeah. Render tile size is and the width divided by the number of X tiles. This is okay. So okay. And with this, I can now update this here, the upper left chord, and of course we have the upper left coordinate, and we add to this the render tile size multiplied. Okay, so we call the nice thing is the offset hyperpasm translate can directly give the amount that we want to translate, and this is X tiles multiplied tile size and tile size, and tile size is not this one, and render width is no longer render width, it's now render tile size. Oops, one of the wrong key bindings. So render width. Now size. Believes that it worked. Hey! Honestly, I'm a little proud of me that I made it correct at the first moment. So let's see if we can see how it go in. Hasn't got slower. That's interesting. Oh, it's good. Let's add a little bit that we really believe what we are doing here. Yeah, let's make it slower. And yeah, I have to bundle view here. Let's just give it a play. Let's just delay by 1 second. Value doesn't interface, we would just see delay. Ah, did you see it? Exactly. This was what I wanted to see. Yeah. So we saw it. It does it in this or everything after another. Yeah. Okay. So we are actually now at a point that we can think about splitting it into the separate isolates. But honestly, I need a little break. I don't know what's about you. We are at a good point now. I will push current state to the oh, let's create a new branch. Stage this. Files. Okay, and continue later at exactly this point, and we'll make in the next step. We will build the actual isolates.